Okay, so we're going to do page 325, numbers 8D, number 12, and number 15. So 8D. 8D says to use the vectors in the previous question, x equal to 2i minus j, and y equal to negative I plus 5j. And it wants you to evaluate the magnitude of 3y minus 2x. So in this, I'm going to substitute in 3 times the vector y, which is negative I plus 5j, minus 2 times the vector x, which is 2i minus j, and I'm taking the magnitude of that. So I'm going to simplify the inside of that, okay, by expanding in the 3 and the negative 2, and then collecting like vectors, and I've got the magnitude of negative 7i plus 17j. And that can be written down as a coordinate vector as negative 7, 17. And we know the magnitude of that is going to be the square root of negative 7 squared plus 17 squared. And that equals root 338. So that's 8D. Should help you out with the rest of number 8. And then number 12 asks, right here, number 12, parallelogram has 3 of its vertices at A, B, and C. So A is negative 1, 2, B is 7, negative 2, and C is 2, 8. You want to plot those. So it says draw a grid and locate each of these points. Okay. On your grid, draw the 3 locations for a 4th point that would make a parallelogram with points A, B, and C. And C is determine all possible coordinates for the point described in part B. Okay, so the 3 different points. So what I've done is I've plotted the points. Okay. A is right here. Okay, so A is negative 1, 2. Okay. And B is 7, negative 2. And C is 2, 8. Okay, so we plot those points, and you can see I've already got the drawings in there. The first parallelogram that I've got is the one that you see here with A, B, D1 I call this, and C. So I've plotted a point over here to make a parallelogram. This side here needs to be parallel to this. So in order to do that, you see to go from point A to point C, you're going to go horizontally from x equal to negative 1 to x equal to 2, which is a distance of 3. So I'm going to go 3 this way, and then I'm going to go from y equal to 2 to y equal to 8. So that's a distance of 6 to go up. So if I do the same thing over here, from B, I'm going to go 3 horizontally, so from 7 to 10, and then I'm going to go 6 up, so from negative 2 to 4, and that gives me that point. That's one way of doing it. Now another parallelogram that you can see, okay, is this one here. So I could have put D over here, so I'm going to call that D2. Okay, you'd have to figure out the coordinates of that point using a similar method. And then another parallelogram that you can see is up here some, is this one down here. So where point D goes below all the points. And I call that D3. Okay, so that side is parallel to that side. And that will be the 3 parallelograms harder to see with this one big diagram. Now, another way, and probably the most important way, to get point D, D1, D2, or D3, is to use vectors. So the vector from A to C, so vector AC, is going to be the same vector as from B to D1. Okay? So we're going to let D1 equal some point AB. Okay? So let D1 equal AB. Then, as I said earlier, vector AC, okay, so from A to C, is equal to B D1. We know those two vectors are equal. AC, if you remember from before, okay, the point-to-point vector, so AC is going to be OC minus OA. BD1 is OD1 minus OB. So that's the way we write these point-to-point vectors. OC is 2, 8. Okay, so from the origin to point C is 2, 8. From the origin to point A is negative 1, 2. From the origin to point D1, well, we said D1 is AB. We're going to soon find out that it's 10, 4. So it's AB. OD1 is AB, and OB is 7, negative 2. Okay? Now, we want to get AB. This is a vector at this point. AB is a vector. So in order to do that, I'm going to get rid of this vector 7, negative 2 from this side. So I'm going to add the vector 7, negative 2 to both sides. And when I do that, I'm going to combine all the x coordinates. So 2 minus negative 1, so that's plus 1, is 3, plus 7 is 10. Okay? So that's going to give me a 10. 8 minus 2 is 6, minus another plus a negative 2 is 4. That gives me 10, 4, which is what we figured it out to be logically up here. Okay, so this is a mathematical method for you to figure this out. Okay, and AB in this case is a vector. We want point D. So then we have to then say, therefore, D1 is 10, 4. Okay, so using the same process, we can look at finding D2. Well, in D2, we know that vector BC is equal to AD2. BC and AD2 are the same vectors, starting from different points, but as vectors are the same. Okay, so let's take a look at that one. And this one I'll just set up for you. Okay, so in this case, we're going to let D2 equals CD and BC equals AD2. Okay, which is what I said. And BC is OC minus OB, AD2 is OD2 minus OA, and you follow through the way we did for the other one. Same thing for D3. D3, let it equal EF, and you'll see that vectors CA, so CA equals BD3. CA equals BD3, and you'd follow through in the same way. That's number 12. Number 15. 15 in the book asks you to find a point P on the x-axis. Point P on the x-axis that is equal distance from point A and B. So the distance from point P to 5 on the x-axis is the same distance from point P to 2 on the y-axis. So in other words, we have the magnitude of vector PA, that's that one there. Okay, So there's PA. And PB, there's PB. The magnitude of those vectors must be equal. So we need to find this point P. Now P, we're told in the textbook, is going to have the coordinates of A, 0. That makes sense. The y coordinate is 0. Okay. And we know that PA is OA minus OP. OA is 5, 0. OP is A0. Subtract the two, you get 5 minus A, comma 0. So that's the vector PA. We don't know what the little a is yet. Vector PB. Vector PB is OB minus OP. Plug it all in, and you get negative A2. So PB then equals negative A2. We want the magnitude of PA to equal the magnitude of PB. So what we do is we find the magnitude of each one. So PA is just plugging into Pythagorean theorem. Okay, 0 squared is 0, so you get the square root of 5 minus A all squared. The square goes away and you get 5 minus A. PB, the magnitude is A squared plus 2 squared, or the root of that, the root of A squared plus 4. And now you're going to set those two equal to each other. PA equals PB. You get this equation. In this equation, you're going to have to get rid of the square root. So you square both sides. Squaring this side gets rid of the square root. Squaring this side, well, you have to put a square around the whole thing. You expand it, cancel out the a squareds, and you've got a linear equation where you get a equal to 21 over 10, or 2.1. And that then gives you the point on the x-axis of 2.1 comma 0. Okay, so P equals 2.1 comma 0 is the point. Okay. B is done in a similar way. You want QB equal to QA, where OB is going to be the point on the y-axis, and you're going to have a vector from there to there and there to there. Okay, so QA and QB. And you'll want to solve that. So you do that in a very similar way. That's it for those questions.